wasn't as controversial. In other words, I'd already been doing it. I could look my wife in the eye, I could look my friends and family in the eye and say, I have been doing this. Now, granted, I've got to do it on a whole nother level, and it's full time now, and we're moving our family and we're relocating. My wife was also going to leave her job. So there were plenty of pretty big risks. But what I didn't do is I didn't quit my job just because I was, ticked off or upset or disgruntled, because that's another mistake. Not liking your day job doesn't give you the credit or increase the odds of succeeding in your newfound, entrepreneurial endeavor. And so I just sort of said, okay, build this business up to a point where I can have the deck stacked in my favor. Tried to save up some cash, avoided debt, and those sort of things I think help minimize the risk as you're pursuing something.
Yeah, you seem like you're a very cautious entrepreneur, and you took your time, you're patient, and you waited for the right moment. That's some great lessons.
I would just say it will work for anybody. It's just most folks don't want to take the time. And that's tough. I get it. People look at our shop now and say, "Oh my God, you grew like crazy." And I'm kind of thinking, well, I mean, I was in 1,000 square feet for 9 years, or 7 years, and 10-year overnight success.
Well, and I think that's funny too, because we sort of live in a world today of the instant gratification, right? Where it's, I have my phone, I can get an answer I want at any time, any moment of any second that I need an answer, and all of that stuff. And I think when it comes to the business component, I think there's a little bit of that pops up too, right? Because there's all this, oh, just go on Shark Tank, or just go over here and do this, and they'll sign you up and you'll get this and it'll just magically work, without understanding the consequences of what happens to a lot of those things.
Right. Mm-hmm. I will say there's no substitute for doing it. You can read the books, you can take classes, you can talk about it, you can plan, but you got to get out there. If you want to learn how to be a machinist, or you want to make job shop work, start doing job shop work. Find a way to get access to a machine and start doing work and take pride in it. If you want to become an Upwork type freelance consultant in the CAD or CAM or design world, go do that. Put yourself out there. Take on customer work and do a darn good job at it. And if you want to launch a product, my advice would be keep it as simple as you can to knock it out of the park. Don't kid yourself that you need margins on those sorts of products to otherwise it's just a hobby if you're not actually going to make a profit. But it's one of the best feelings in the world. To this day, I get a pretty solid endorphin release when orders come through the site and, hey, someone wants to buy something you made. It feels good.
Mm-hmm. With your podcast and some of the videos that you do, what are you seeing out there as far as industry? Like, one of the things that we see on our side, for example, is we're seeing a lot more engineers thinking about manufacturing, doing the prototypes. Our mutual friends over at Tormach are seeing that a lot too, where designers are becoming equipped enough to actually make parts. What do you see from your side as you talk with different people around the country?
I would definitely agree. You're seeing less of the examples of where design engineers, industrial engineers, mechanical engineers, have no clue what the subtractive world is like and how that can relate to the design of a part. And that's a good thing, right? But it also is the case that as we see more and more technologies come about, 5-axis is far from new nowadays, and subtractive manufacturing, hybrid manufacturing, that just increases the increases the abilities and complexities of parts. So it's kind of a constantly moving goalpost, if that makes sense.
Yeah.
Yep.
You see more and more with tooling. Tooling is probably the thing I have become the most fascinated with, partly because it's kind of cooler than the machine tool themselves. The cutting tool is what's out there, different technologies, different styles, different holders, and how that is a force multiplier for, take your example, your Matsura. That's not going to handle high-speed machining tool paths. That's okay. They can still make good parts. So what do you do with that? How do you get the most out of that I'm guessing it's probably a box weighed machine. How do you get the best removal rates? How do you get the best surface finishes? How do you get the best tolerances? That to me is cool.
Yeah, I run volume mill on mine. I don't do it for the high speed reasons of like what you would get on a brand new Haas or a brand new Matsura, but I do it more for extended tool life than anything.
Okay.
I'm limited by horsepower, to be honest. But I just do it more because like what you were talking about, the consumable aspect of it, right? Like if I can extend the life of my end mill by two times even, that lowers my overhead when I actually have to make a part, right? Versus, just going at it wide open, maxing everything out, and then eating tools like crazy,
Right.
Yeah, I agree with you. Tool technology is amazing to me. I love what people do with stuff, and I love understanding how machining has evolved based around the tool technology, because let's face it, X, Y, and Z has been X, Y, and Z for a long, long, long time.
Yeah, agreed. And it's interesting because it's not just wearing tools out, but it's that process reliability. You probably don't care if it takes 20% longer or 10 minutes longer, but when you're taking those really open, high-speed machining style cuts that are really evacuating the chips, and it's unlikely that you're going to chip weld or clog up or recut parts or recut chips. It feels good to know you've got a safe recipe.
Yeah. Trust me, if I won the lottery tomorrow, I would have a new Matsura in my shop, but and then I could take advantage of all of the cool stuff. But yeah, I agree with you. I mean, for me, to be honest with what I do with mine, I can afford it to take a little bit longer. I don't have that much overhead. So I can make a part for someone that's cost comparable. It just may take me a little bit longer to do, but I'm also, I have a day job. So,
right.
My day job supersedes anything else that's going on.
Right. I think the other thing that I see is, what is the definition of a machinist? And, you could debate that for quite a while, but what I'll say is when I see some of the shops that I look up to, the shops that really leave an impression on me, I was in the Netherlands about a month ago, and there's a shop there where, it's a relatively young group of folks. And what is a machinist? Well, it's that ability to understand fixturing. It's the ability to do parametric CAD, to do intelligent fixturing or reusing fixturing or automation. It's working with the UR robot. It's working with 5-axis toolpaths and simulation. It's doing JavaScript edits to a post processor. And it's, knowing what a torque wrench is and how to not use one. So it's really interesting to me that, who would have thought you would have things like, again, editing JavaScript and simulation software, but then also, being very mechanical with things like wrenches and setups and vices and so forth.
Yeah, it's definitely evolved a lot from the early days when I got out of school and you had to learn how to, do manufacturing. Today's world is way more digital, and having that basic understanding of computers is way more important than ever, on top of the mechanical.
And it's not even just the comfort with computers, it's the comfort to tackle, kind of the unknown. I think that's a good kind of entrepreneurial skill set. It's know what you're good at, but also be comfortable with what you're not good at, but then be resourceful enough to find the answers. So you may not need to know JavaScript, but you need to know how to look for the person on, I always say Upwork, some sort of a website or freelancer or something, to ask the right questions and say, hey, I need your help modifying this post or this file format. Here's what, be able to articulate the question and get the result you're looking for. That's a important thing to be able to do.
Yeah, that's some great problem solving skills right there. Even if you don't have the skill set, it's where do you find the skill set? How do you reach out?
What question do you ask?
Right. And you're right, John. I mean, so much, there's so much more digital technology involved with just being a machinist. It used to be, years and years and years ago, it was really about understanding, your math needed to be pretty strong, right? You needed to be able to do trig. You needed to be able to use the machinist handbook, which can be challenging. You needed to understand surface footage and how to break a chip.
Mm-hmm.
You needed to educate your ear what sounds right, especially when you're running a lathe or something else. You can tell by your ear when something isn't running. But nowadays we've got all the software, which gives us a huge helping hand, right?
Yep.
And the ability just to find your way around software quickly, efficiently, and be able to utilize it to its maximum value is part of being a machinist today. It just is.
I was in a meeting, that's probably 3 years ago, and that question came up, which was, should we still be teaching, manual machines in the trade schools? And somebody rebutted, controversially saying, I don't think we need to worry about manual machines so much. The kids need to be able to write G code, which is kind of the answer I've heard before. And then somebody else, the person who was a pretty important person in the industry, chimed in and said, I don't care about G code. I would rather hire a 17-year-old who can modify a post but can't write G code by hand. That's more important to me in modern manufacturing. And I think there's something to be said for that.
Yeah,
it's interesting.
Go ahead, John.
Yeah, well, it's interesting because in order to modify a post, you almost have to know G code. It's kind of they go kind of hand in hand. And but you're right, John. Being able to modify post processors today is one of the big issues that we face every day as a machinist. Being able to do that and understand the different languages that are involved as we compile post processors and use them. Yeah,
and I'm picking on posts, but it's Grimsby and I talk a lot about writing custom Renishaw macros or doing in-process sort of QC checks. And I will say this: I have never once in my life written a G code program from hand by scratch.
Really?
No. I mean, I could figure it out for sure using some resources, and I know the basics for sure. I mean, I know M codes and G codes, but to actually write a program, I have never done it, never will do it. And you're right. I mean, you've got to understand certain things, but when I'm trying to figure out how to put a G30 in a post somewhere, I just look for the other examples. I've got those hacky kind of skills. Kind of goes back to the Arduino days of writing Arduino code. You don't write that from scratch. You find tutorials and libraries, and then you modify them and tweak them, and you put comments in so that you can sort of do your own debugging to see, well, if it errors out here, which comment got listed, because that tells me what the code I'm editing is happening.
You're absolutely right, John. In fact, when you get into programming like that, you may figure it out one time and you'll write it once, but you'll never write it another time. You know where it's at, and you'll copy and paste that code and you put it all together. And I'm sure you did that with your Arduino, and you kind of do that with code when you're using post processors as well.
Right, which is fun. To be honest, in terms of my daily life, I miss having the time to really pour yourself into that. Actually, Grimsby and I were talking last week on our podcast about how I think a really good lesson that I could embrace more, and I think any entrepreneur could, or especially a small business entrepreneur, is to kind of think like a surgeon. And this came about recently because my wife had to have some surgery done, and I just thought, that surgeon has this ability to take his patient, close the door, and he has a support team around him, and nothing else goes on for X number of hours. There's no text messages, there's no WhatsApp, there's no social media, there's no phone calls, there's no emails, because all he cares about is pouring 100% of himself into succeeding at this task. And I think it's pretty easy as an entrepreneur to end up bouncing around, putting out fires and doing a lot of different things, when in reality what you want to be able to do is say, hey, I am going to figure this out. I am going to work on this, and thinking like a surgeon, I think, is a really good way to get that result.
I think you're right. The ability to put all of these distractions aside and just get lost in what you're doing is just a phenomenal way to solve problems.
Yeah, and it doesn't, if that surgery takes 9 hours instead of 3, surgeon doesn't care. That's the only thing he's worried about in the world is the patient on that operating table, period.
Right. And, it's interesting, but you're right. Solving problems, in the CNC shop is similar to that. Especially when you get into, doing complex fixturing. I know that I could sit there sometimes and I can spend hours looking into space just trying to visualize how successfully create a fixture that's going to remove couple of different setups or improve an operation, and it'll finally come to me, and I'll finally get it. Yeah, there's nothing like being able to focus 100% on some of these manufacturing challenges that really make a difference.
What is your, if you don't let me share, what is your, do you look at old fixtures? Do you sketch out on paper? Do you hop into SolidWorks? What's your workflow there?
Well, usually the very first thing I do is I go back into my mind with any experience that I've got. And if there's something that, if I see a problem that I'm trying to solve, I'm trying to do this in one setup instead of 2 or 3, I think back within all the fixtures I've seen or anything I've designed, and is there anything there that I can use? And if not, what I'll do is I'll typically go on the internet then. Right? I get that information flow, and I'll start to Google specific fixtures and see if there's anything out there. Just take a deep dive into fixtures, and I'll do it visually as well. I'll just go to images, and I'll start to do that and see if there's anything that gives me a boost, something that gets me there. And a lot of times there isn't, because it's a unique problem or unique part. And I'll just sit down and I'll just start to think my way through it. What is the quickest, easiest way to get this done? And yeah, eventually, then what I do is I start to take my concept and I do bring it into a CAD system, which would be SolidWorks, and I start to model it and start to see, gosh, I'll even model double step jaws in order to do a machine complete job on a lathe, just to make sure that I can turn it around, all the clearances are the same, everything's cut right. I'll definitely go to a CAD system and then prove that out.
Yeah, it's interesting. I struggle. What you said sounds great, but I would not. I would put too much pressure. Kind of like what they say with writer's block. Of if I just tried to close my eyes and think back, so for me, I found I have to take a different approach, which is I have to. We basically have 3 or 4 different ways that we hold stuff, we fixture stuff, and we're good at it. We know how to use these clamps or this style. It's common stuff. The super glue, the soft jaws, mighty bites, talons, like that kind of stuff. Right. We're good at it. We have them on hand. We've done a lot of different things with them. We know where they're not good. So how do you overcome that? And I just sort of actually in my head, I try to fixture all those different ways, because darn it, if I can make it work with one of those, that's how it's going to be. And if it doesn't work that way, then I do what you do. I've got a folder in my computer with 150 fixtures, and I just start hitting the right arrow key, looking through them to see what starts jogging my memory.
Right. Yeah. By the way, I use tail-end grips too. They're just phenomenal. I just love them.
Yeah.
And one of the things that I sort of follow a mix of both of you, and then I have some buddies that still machine every day, so sometimes I call them up after work and I'm like, hey, I got this challenge. What are your thoughts on it on top of it? But one of the things John and I have been trying to play with a little bit here too is wrapping our mind around using additive for fixtures and jaws and support. So that, to me, that's a whole new world of trying to figure out when, where, how, and why those could be used. Because, it would be, there is some advantage of hit the print button and the next morning you have the jaws or the fixturing that you need to just go machine them.
Yeah. We fell down that rabbit hole. We upgraded from a regular, extrusion printer to a Mark Forged, which has been pretty awesome. But we sort of thought, okay, let's make soft jaws, and so we made a set of soft jaws, and they didn't really work. They didn't work in terms of what you would consider acceptable for a machine shop environment. And I was kind of bummed. And then I realized we're thinking about it wrong for now. Don't get me wrong, there are probably soft jaw scenarios or different printers that would be okay. But where I think they're better is a little bit more of a complement. So anytime you've got to do complicated setups, custom 3D print a locating fixture. It can serve as your coordinate system. It can give you custom angles. It can give you spacing on parts. If you've got a strip of Mighty Bite pit bulls and you need to space them out, print a 3D fixture that has little tapered spacers on one strip that you just lay in there that automatically self-spaces everything. And then you can put a ruler over it to make sure everything's seated down correctly. So we think about it more as gentle complements instead of this kind of brute force. You're just going to 3D print the whole fixture.
Yeah, I think that's a great perspective. And use it where it helps and where it complements things easily.
Yeah.
No, that makes a lot of sense.
When you tried to do it, so the question I've been trying to get answered from some places is I'm trying to keep an open mind about it. How did the parts you printed react to coolant when you tried it?
So it's hasn't coolant itself hasn't been a problem. The Mark Forged material is, I'm going to mispronounce this,